Thank you. I'm super excited to be here. First time speaker at this awesome conference. Long time follower, and I guess 2020 dreams come true. Uh, always make sure that you know what you're wishing for. All right. So let's get this going, folks. It's really exciting. I will try to feed as much as possible material for this presentation. For this short time, we will we'll have a lot of things to cover. So without further ado, let's do this. All right. So just to make sure that everyone sees the slides, hopefully, I'm not gonna be checking um, the chat like actively because I will be focusing on doing the presentation. But hey, here I am. Okay, so it's not my projector, right? It's a screen share. So hopefully you'll see the screen share and everything is working, and like everything is clear. Okay, so this is talk about Kafka Streams. It's I call it Kafka Streams 101. If you didn't know anything about Kafka, if you didn't know anything about Kafka Streams, it would be a good talk to start with. In my goal in this talk is just like give you idea and maybe provide some of the resources, not maybe, definitely provide you some of the resources where you can start learning things around stream processing and Kafka and so far and so on. I work as a developer advocate here at Confluent, and I like to steal this line from my fellow developer advocate, Kenny Bastani. I build highly scalable and highly available hello world applications. I think it's appropriate for this type of for this conference. So hopefully this is going to be useful and entertaining for everyone. So let's start with this one. We're going to be talking about stream processing. Stream processing is a process of having your processes or like dealing with this event as they arrive into the system, meaning that we're not waiting to accumulate them and after that, to run this processing at the end of the day. We're not waiting until all these events will arrive. We don't know when all of these events will arrive. So it's a difference between systems like a batch systems where you waiting for this events to arrive and have to do something. It's even different from the system that do so-called like micro batching when they waiting for a little and after that they apply the computation. In stream processing, you are passing this message through the computation DAG or pure computation pipeline, and you're doing this for every message. And it's up to your process, it's up to your application that will actually tell you what's going to happen with this data. So we're going to be dealing with this. In more realistic example, like we do have lots of events that come in from the mobile devices, that come in from other systems, or from different sensors, maybe even from many other places. So in order to capture those events and like to start making sense of it, we usually capture those in event streaming platform. And these days, Apache Kafka is usually the default choice for a streaming platform. It provides known capabilities for scalability. It provides known capability for durability of the messages and so on and so on. So we do have these events. We captured those events in Kafka. Kafka provides a buffer that allows our processing logic that will be implemented in this particular case. We're going to be talking about some of the Java apps and the Java particular things, but it not necessarily needs to be Java. It's something different. There's plenty of different tools in different languages, or even can be tools that agnostic from any programming language like KSQL that provides you like SQL-like interface to deal with this. So, and another important thing that's usually not the part of this processing logic is the server logic. This is essentially, if you've been in this world of the data engineering for a while, you know that this architecture is very much looks like it's couple architecture, right? So there was a Lambda architecture where you have a multiple layers, there's speed layer, there's batch layer, but this is couple architecture where you are fully processing the layer. Now, A serving layer, usually it's something that using some other system, like when you do the processing, you offload this into the system like Hazelcast, the Redis, Cassandra, Elastic, something that allows you to fast access for random data. But Kafka Streams, as a matter of fact, provides these capabilities that you can combine this serving layer and your processing layer together. I will talk about this just also a little bit. Now, so let's talk just very briefly, for those of you who don't know what's the Apache Kafka, just really briefly, I will introduce to this concept of event streaming platform. All right, so in the world of event streaming platform, we do have Kafka brokers that essentially doing the work around storing your data, capturing this data, making sure that order is in point, making sure that data is replicated properly. As of today, what date is it today? Today is the 12th of November 2020. Kafka still depends on Zookeeper. There is ongoing work around making Kafka lighter or maybe making Kafka smarter to put more the consensus logic inside the Kafka brokers and get rid of the additional dependency that simplifies deployment in many cases, and especially in the cloud native world where distributed system needs to be dependent on less dependency as possible. So for now, it is there. So usually, in order to deal with this data, in order to integrate the system with Kafka, you are using the library that talks native Kafka protocol. And this protocol is highly efficient. It's a binary protocol, runs on top of TCP/IP. You don't need to implement any kind of like a load balancing logic, because Kafka, as a modern distributed system, also follows like similar ideas that many other distributed systems follows in terms of like how to access to particular data. And I'm talking about some sort of version of consistent algorithm, right? When the clients will have a connection to all brokers, and after that, on the data, they will figure out which broker to choose to write. So next thing is that Kafka essentially don't care what kind of data you store there. You don't care. It doesn't care if you put there strings, JSON, pictures, files. I do care, and I'm against this. But hey, we can have this conversation. So one of the things that people started realizing that is Java serialization is not very portable. So this is why if you're serializing Java object into something that you want to read, for example, in Go language, that would be really tricky. So in this case, some of the intermediate format of serialization should be chosen. And this format can be protobuf, this format can be Avro, even JSON may be okay, because the people still convinced that the JSON is a good language for inter-system communications. For some reasons, they say, oh, it's a human readable. It's a machine readable, but the format is allowed you to use and read this using this editor. So maybe some other tools that allows you to read, for say, protobuf payload, it also would be human readable. But anyways, schema registry allows to store this information and provide the schema for applications when application need it. So in this case, if your application going and receiving some message, you don't need to have whole full-blown information as a part of the payload. You can have a tiny payload, which is going to be binary compressed or like binary generated, and after that, schema registry will provide the rich view on this one. And on the client, you can decompress it and or like deserialize it and get the right result. The native libraries usually considered as a kind of like assembly language for Kafka applications, and I will talk about this, and you will understand why native library producer and consumer is an assembly language for this. Kafka Streams is a high-level API, that allows you to focus on what you actually want to do with your data, rather than okay, so I'm reading the message, and after that I need to write the filtering logic or transformation logic like over and over, or maybe worry about the state, where to store it, and so far and so on. So Kafka Streams, we're going to be focusing on the Kafka Streams today. There's some other tools like KSQL DB that allows you to write the application without knowledge about Java, because it's just like SQL. You deploy the SQL, it will run this, and it's actually full-blown stream processing application. There are some applications that not necessarily able to deal with the native protocol. So for example, you want to produce message from curl for some reasons. You want to write the message to Kafka from curl, or you're parsing logs and you want to do this. So you can grab this and pass it to REST proxy. REST proxy is essentially it's exactly what it sounds. It's this interface that allows to produce data to Kafka without writing like native application. And there's Kafka Connect that allows you to integrate with any other distributed systems or any other systems for that matter, like databases, messaging queues, and so forth and so on. That allows you to bring data in and takes data out. Like when you do processing, data stores in Kafka back, and after that it offloads back to I don't know, data warehouse or some of the search storage like Elastic or so far and so on. Let's take a look quickly on how this application looks like. So the producer application, how does it look like? So the typical idea, typical cycle of Kafka world. We read something data from Kafka, so we're getting this event one at a time. So this is why we have this infinite loop, and it's okay. You know, you can say like, Viktor, we have an infinite loop. One of the things that justifies it, and this infinite loop is actually not a bad thing. It's an architectural pattern. The good analogy that I heard, and I'm using this all the time now, is that the Kafka consumer is like a shark. Have you ever thought that what's going to happen to shark if shark stop moving? Like, have you ever thought about this? Like how shark will be sleeping? It doesn't, because if shark will stop, it will die. Same thing happens with consumer. If this the constant pulling logic will stop, a consumer will die. But let's break this code real quickly. So why we need to have a hash map? Because we want to deal with a stateful stream processing, meaning that we want to have ability to calculate current step based on some previous results. All type of aggregations, all type of transformation that might have information from the past will require on count, calculating minimum, calculating maximum, calculating averages. All these things will require state. Usually systems provide the pluggable storage solution. For example, you can bring some database, but in this example, I'm using like a super fast, somehow fast, maybe not super fast, somehow fast hash map that allows to deal with this storage. And the reason why we're using this and the reason why we need this is after we subscribe this, we run this infinite loop of pulling messages from Kafka topic. And only one thing what we need to do, this is actually one logic that we're doing. We need to improve count. So it's a very simple example of, you just want to have a count because it's very simple example of stateful processing. And after that, once you're done with this, once you calculate this, you can save it somewhere. In this case, you have a producer. So again, logic is simple. We have a consumer that reads data, processes data, and produces back. So this is what a cycle of Kafka application looks like. Many people have this idea that end-to-end Kafka application should look like producer, Kafka broker, consumer. No, it's actually another way around. So it's a consumer that constantly reading data. It's a processing that runs inside the consumer, and producer that runs as a thing that writes the result back to Kafka. So, and after that, we need to tell consumer that, hey, we're done with processing. And usually people fine with that. Usually people love this. Usually people who probably get paid for lines of code that they develop, they love this type of code. And sometimes I'm even having a hard time to convince them, because people are seeing no reason by bringing something that simplifies their lives, because they already satisfied with some of the consumer producer pay. Maybe I have a theory that the people who chose this path, they are framework developers. And as a framework developer, you always need to go in the lowest level possible. So instead of developing your own client, you probably rely on the producer consumer API and implement framework around this. All frameworks that you will see these days that talk to Kafka somehow, they are using consumer and producer API anyways, like in one way or another. Or they may be even implementing their own protocol, which would be No, probably, but you can implement this, but I don't see reason why you would. So let's talk about the framework of this, right? So you have framework developer, and how you're going to deal with this. So let me show you some of the code that does the same thing as we discussed in the previous step. Remember, constant loop of consuming data from the topic, and doing something with this data, and let's see how it looks like. So this case, this is, I can say if I would just strip some of the configuration, for example, connection to Kafka broker, things like that. This is full-blown application that implements Kafka Streams. So this application also reads data from the topic. It does a count and the save data in another topic that will have a grouped version, grouped by key, the counts. So there's a lot of things that this teeny tiny piece of code does. And specifically, it allows you to just in a few lines of code, just do grouping, implement some of the very often useful, some of the operations that you probably will be doing very, very often, specifically group by key and counts, this type of thing that would be there out of the box. And after that, store the state somewhere in case of new data will arrive, and you will need to continue this calculating this the data based on the new data. And also, you want to store the results so other systems will benefit from using this. So in this particular case, that's how you would do this. And this is it. This is topology that allows you to focus on how this message would be transformed rather than focus on producer and consumer. You don't see producer and consumer here anymore, right? It is there. And this framework provides you with different cool things. I don't know how about you, but like I think it's pretty impressive, right? When you replacing some of this like a code, the multiple slides that using with a few lines of code. So why it is important? Speaking about the frameworks that the people develop, like if you would start developing your own framework based on some of the stream processing framework, what this framework should be capable of doing. So these days, running single machine workloads it's possible. It's many frameworks still doing this, and it's probably okay. However, it's not like future-proof, because once the load of the data grows, you want to deal with this accordingly. So framework should be scalable. So how you would do this? So there's some of the Lego blocks that Kafka protocol and Kafka consumer protocol provides in order to scale this load. For example, Kafka consumer groups and Kafka partitions allows you to parallelize consumption. So if you have a topic with 10 partitions and you want to read in 10 times faster, just start 10 consumers that will join one consumer group on each topic, and each consumer will be reading particular partition. So the scalability would be nice to have. Elasticity is also a very good point. Like once you start scaling, you want to scale elastically. You don't want to small application build multiple cluster of multiple machines. You want to start slow. You want to see how does it work, and like you want to learn the framework. You want to learn how the things are happen. And after that, you can grow from the smaller use cases. Maybe like you just like want to put some of the data into Kafka and start processing. And after that, you can grow by bringing more data sources. Failure is inevitable. There's no way how you can avoid failures. However, it's only a question how you would handle with this. And there's different guarantees that different system provides, how a system will behave under certain failures. We know from different lesson learned from the scalability and the design of data systems that network partitioning usually always inevitable. It's very difficult to build highly reliable network. except if you're not in a business of building high reliable network. But in general, when we're talking about general purpose frameworks and general purpose data systems, network partitioning is inevitable. Like if you're running this in the cloud, probably will happen to you because you're not managing this infrastructure. Or if you're running this in your data centers, you're also not managing your data structure. Your system administrator might be taking care of this. But how you can be tolerate to failures, it's important. Like what you will choose, which you choose, like consistency over availability or availability over consistency. And this is decisions that needs to be clearly stated by a framework for data system in order to people to use in this one. Stateful is hard. So because the managing state, especially managing state in this world of the clouds, is also like difficult, but it's important. You cannot be just a very good general purpose stream processing framework or like data processing framework without ability to save intermediate steps or somehow take care of the operations that will require some of the knowledge of the past. So that's very important, and it needs to be working obviously in distributed fashion. Now, next question, and very important question that usually designers of the system should ask themselves: where do I put my compute? Like if you've been here in a Hadoop world, where did you put your compute? So there's multiple things. So essentially, you have a driver that needs to you compile your code, you put it as jars, and now you need to deliver this to your computational cluster. Same thing with the Spark. You compile this, you deploy this in the cluster, and resource management needs to be happening. So this is very good questions where your computing is running. And sometimes, like when you're trying to debug system and they're trying to understand like where are my things, it's not very clear. Where's the state? Remember, I was talking about this kind of intermediate thing that needs to capture what's happening in your system, where it goes, where the state is going. It's important. And important question, where its code goes. So essentially, this is the question that many data engineers and data architects were asking when they're evaluating any type of processing system or data system these days. Like there would be a myriad of the ways how the system will behave. Kafka Streams is a Java API for building applications, not building clusters, not building jobs or managing resources. It is API that runs inside your application. However, it provides you cool capabilities. For example, like if we take this small application that follows the pattern that I was talking about the pattern of constantly reading data from the topic because we're expecting data to arrive. Once we receive this data, we do processing, and this processing is constant. Nothing runs in the brokers. Even though Kafka Streams is a framework that comes with Kafka, it not runs inside the broker. So it's not running inside the broker. So this framework allows you to scale of your processing if you feel that one instance is not capable of consuming messages fast enough. And with this built-in protocol of scalability, you only thing that you need to do is just like spin up another instance of application, providing the same application ID. And after that, Kafka Streams will handle the coordination and will handle data distribution. It will handle which application instance will handle particular partition and topic, and so far and so on. So I talk a little bit about this Lambda architecture back in the day, and this is also like simplified. Something wrong with my slides. My dashboard D somehow went out. But essentially, this is an example of Lambda architecture. There's a processing cluster. There's some job deployed to this cluster, and there's some shared database that would be populated with results. And after that, there's some microservice. There's some other system that will display this in in UI. Now, how this Kafka Streams fella change this situation? That's pretty much it. So your Kafka Streams application might include other things. It might include some of the front-end elements because it's just a library. It's a library that runs inside your application. If you run this any popular microservices framework like Micronaut, Spring Boot, Quarkus, some other things, you can use Kafka Streams there. So you're using all benefits of existing Java infrastructure, or for that matter, JVM. It doesn't really matter if using the Java language or Kotlin language or Scala. I don't. I use Java or Kotlin. But hey, there is a native API for Scala in Kafka. In fact, so in this pattern there's a bunch of good examples internally. Like we also at Confluent, we do have the commercial product called Confluent Control Center. In Confluent Control Center essentially is a Kafka Streams application. It's a dashboard that allows to monitor your Kafka cluster, but it actually Kafka Streams application, full-blown UI. It has all nice graphs that showing what's going on in the cluster. And importantly with this, like where is your code? Your code can be deployed anywhere. Like it depends on whatever tools and technologies your organization is using. You can still follow this. If you're deploying this in Docker, if you're deploying this in the VMs, if you deploy this Kubernetes, if you're using Ansible and Terraform and things like that, it really doesn't matter. So as long as you know that application can be packaged as something that's deployable to this particular platform, you will be golden. So that's going to be fun. So there's multiple cool things. It's a great opportunity for me to be there and speak to you about this, and I hope I will spark some of the interest about the Kafka Streams. So what if you want to say, like, I want to know more about this and I want to take my hands dirty? So there's a fantastic resource called developer.confluent.io. It's my team and developed this the website. This is the landing page of all your learning experience. It's my second favorite place on the internet. Like if you want to know why it is my second favorite place on the internet, click to this link that you have this like this one, this link, and you will get the idea why it's my second favorite place on internet. As a part of this the developer.confluent.io, there's a fantastic resource called Kafka tutorials. It actually gives you 10-15 minutes lesson where you can just go follow along, copy paste, and you have runnable application. No need to install anything except Docker, because some of the infrastructure like a Kafka, Scheme Registry, Zookeeper will be shipped in the Docker containers. The rest of the stuff will require just a Java installed on your computer. So check this out. It's fantastic. It's my favorite little friend, and I hope you will find this useful. You can always find me in internet and ask any questions. I'm always in Twitter. I recently started doing a kind of like a weekly live streams in my personal channel. It's YouTube/Viktor Gamov, or Confluent channel, YouTube/Confluent, where I am talking about stream processing, answering the questions, and do all kind of cool stuff around all these things that we will be like that excites me, including some of the DevOps capabilities, including some of the things around how to deploy this, how to solve not the first day responsibilities in terms of like what the app is doing, but the second day, like monitoring maybe, or some of the upgrade and other things. So for that, thanks for sticking around. My name is Viktor Gamov, and as always, have a nice day. I'm open for all possible questions. And that would be great. So question here, difference between Kafka and Apache Spark. So Kafka and Apache Spark, there's no difference. It's a different system. Apache Spark, it's the processing system that allows you to do processing with data. And Apache Spark works with Kafka fairly well. There's a connector that allows you to use Kafka as a source for your data. Kafka is the general purpose event streaming platform that provides the ways how you can capture events, how you can store those events, and how you process those events. look into SBTB Cloud channel in Discord. Maybe there are other questions anywhere else.
So yeah, thanks, Victor, for the session. I'm sure there is also a spatial chat room that the attendees might go, so you can connect with them.
Yes,
and,
as a matter of fact, I will do this right now and after this talk, and I will hang out for some time there. Sure. Even though I'm not promised to stay for a very long time, it's even though I'm virtually with you on the West Coast, I'm physically still on East Coast, and it's getting late here. So